Hey guys, welcome to lesson 11. We're just going to backtrack into Algebra 1 again, looking at polynomials so we can get ready to discuss quadratics as we move through this next unit. Make sure that when you're writing down your notes, you divide your paper over here on this left-hand side, leave room for the questions, and don't forget to write down your EQ, that essential question. Today we're going to talk about adding and subtracting polynomials, and then again about the rules for multiplying and dividing with exponents. It all kind of works together, but there's lots of little detail pieces that you've got to remember and pay attention to. So this first piece right here, we have 3x, no, just a 3, a 5x, and this negative 2xy squared z. These are just three separate examples, and these are all individual units. So the 3, the 5x, and that whole piece. They exist all as one unit, and we call those monomials. Oops, you didn't need to see that, sorry. It's a problem with the touch screen. Anyway, these are monomials. Remember that the prefix mono means one or single. Down here we have units that are banded together by plus and minus signs. So this all goes together, and then this chunk all goes together. There's 2 in each set, so those are binomials. Remember, the prefix bi means 2. So then lastly down here we've got this one right here that has 3 separate pieces. The 3x squared, the negative 4x, and then the positive 2. Since there's 3 of them, I bet you can guess. It's a trinomial. All of these fit under the category, which is our title back up here, polynomials. Poly, the prefix right there, simply means many. So many terms down here, there's single terms, 2 terms, 3 terms. It doesn't matter how many. You could go up to a gazillion, I guess. They're all polynomials. Also remember back to Algebra 1, we talked a lot about like terms. That's when you have the same variable with the same exponents. Once you have this condition right here, then you can actually add or subtract. If you don't meet that condition, remember it means you just have to leave it alone. So I've got a couple of examples here for you. They look really, really similar, but one is a set of like terms and the other one is not. This one's a yes, because you'll notice they both have an x to the 1 power and they both have a y to the 1 power. See right there? That makes them like terms. Oops. Down here, this is a no. They are not like terms. They look extremely similar, but they are not, because this one has a plain old x. This one has an x squared. That immediately makes them very different. So you could not add those together like it says. You just have to leave it like it is. We use that in an example like this one right here, where you've got a polynomial and it's telling you to do stuff to it, like add these together and then subtract and then do some more adding. But you can't just go adding numbers because you see them. Pay attention to that like terms thing. 5m and 3n are not like terms, so you can't do that piece. You got to look through here and see if you can find any more m terms, m to the 1 power. I happen to see one right there. Now you can add the coefficients. So you get 13 m's. If you got 5 m's and 8 m's, that's 13 m's total, right? Then you can look right here. Positive 3n and a negative 6n means that I can do that because they're like terms. They both have n to the 1 power. So I end up with a negative 3n. I'm going to box it at this point because an m and an n are different. It's like apples and oranges, and I can't squish them together. So it just leaves me with that binomial. This next one is just where you're going to multiply a monomial times this trinomial inside. Remember, it's just a distributive property, so you just have to watch out for your variables and make sure that you are taking care of those pieces, and watch your negatives too, of course. So 2p times negative 1p is a negative 2p squared. Because remember, p times p is p squared. Then you multiply times the next chunk. So 2 times 3 gives you a 6. The p times r is just a pr. Don't forget that last term down there. 2p times a negative 4 is a negative 8p. Before you box this thing up, make sure you look through to see if there are any like terms. I've got a p squared, a pr, and a p. None of those have the exact same variable with the exact same exponent combination. So I'm just going to leave this guy as it is. That would be my final answer. Scrolling on down, now we've got a binomial times a binomial. Some of you learned this as FOIL, others of you learned it just as the distributive property. It doesn't really matter which method you learned. Just remember that you have to multiply everybody times everybody in whatever method you use. Some people even learned the box method once upon a time, and they're all perfectly workable. I'm going to use distributive property, and that just means I'm going to do the 2a times this guy to get a 6a squared, and then the 2a times this guy to get a 2, nope, not a 2. 2 times 4 is 8ab, because a right here and b right there. There's nothing else over here to multiply by. I don't need to distribute any more there. So now I'm going to take this negative b and multiply it through. So I get a negative 3ab, and then I get a negative 4b squared right there, because there's a b times a b to give me b squared. Again, you don't want to box this thing up until you look for like terms. As I scroll through this, I look for a squareds, and as I run through, I see there's no more a squareds. So I'm going to leave that guy as is. Next, I'm going to look for ABs, and I see that we happen to have 2 of them. So 8 ABs minus 3 ABs leaves me with 5 ABs. Lastly, I've got a negative 4b squared. There's nothing else to even compare it to because I brought the rest down. So now I know I'm done. This last one I got for you right here, oh, just kidding, second to last one, is where you want to come back and remember your exponent rules. Alrighty? Whenever you see a situation like this, alrighty, you notice there's no plus or minus signs in here. This is simply a monomial times a monomial. So you're just going to multiply all the pieces that are alike together. So start with the coefficients. 2 times 5 leaves me with 10. Then I'm going to jump over to the x squared and the x. So x squared times x gives me a total of 3 x's. So x cubed is where that comes from. Then I'm going to look at the y's. I've got a y cubed and a y squared. That leaves me with y to the 5th power. And finally, find a good color, I've got z and z cubed. That's 1 z here and 3 z's there for a total of 4 z's, or z to the 4th power. That's what that equals out to. If it helps you, if you're wondering like where all these exponents came from, think of it this way. Let's look at the y cubed and the y squared. And I'm going to take this over here just to show you where I got the answer. Y cubed means to do it 3 times. Y times y times y. Y squared means to do it 2 more times. Y times y. So here's my y cubed and there's my y squared. If you put it all together, you just think, well, y 1, 2, 3, 4, 5 times. It's easier to say y to the 5th power than y times y times y times y times y, right? So that's where that guy comes from. Does that make sense? You could simplify this down just a little bit out here to the side if you wanted to by simply saying add exponents when you multiply like bases. A like base would be something like y and y. Y is the base, and the 3 and the 2 are the exponents. So since the y's are the same, I can add 3 plus 2, and that's where I got the 5. That's the fast way to do it. I was just kidding. There were 2 more problems. Haha, sorry. So this one right here then. This is the same situation as we had above, except we've switched from multiplying now to dividing. The same rules apply, though. You just are going to go backwards. Instead of multiplying, I'm going to do what it says right now, and I'm going to divide the coefficients. 10 divided by 2 leaves me with 5. Then I switch over and say, okay, well, I've got x divided by x. Well, what's anything divided by its exact self? It's just 1, right? 5 divided by 5 is 1. 10 divided by 10 is 1. X divided by x is 1. We essentially say those cancel out. Okay, remember that canceling out doesn't mean they just magically disappear. Poof! It means that they're mathematically that we don't have to write it for some reason. In this case, it's just a 1, and 5 times 1 is 5, so don't write it. This next little chunk we got over here is y squared divided by y. All right? Y squared divided by y is simply y. I'll show you why in just a minute. Lastly, I jump on just a little further and I go z to the 5th divided by z cubed, and I'm left with z squared. That's my final answer. To show you how I got the y and the z squared there, let's take the z's right here and let's expand it like I did a minute ago. Z to the 5th power is this, right? Z 5 times, and I multiply it. On the bottom, I have z 3 times. See that z cubed? Well, we just discussed over here with the x's that anything divided by itself cancels out. That's all I've got going here. Look, those z's cancel, and those z's cancel, and those z's cancel. So look what's left. Z squared. There's 2 of them. That's where that comes from. Alrighty? Let's write out the rule for that one now, just like we did with the multiplication. Subtract the exponents when you divide like bases. Again, if you look right, oops, just kidding. If you look right here at the z's, the z is the base in both cases. The 5 and the 3 are the exponents. 5 minus 3 gives me the 2 right there. Last one, for real this time. This is really the last one. This is telling me to do a binomial squared. Well, just like we were doing a moment ago, what does that little square right there mean? It just means to do it 2 times, or if it was a 3, it would mean do it 3 times, or 4 would do it 4 times, and so on. So I'm going to take this and do it 2 times. Now y'all know that we can't just leave it like that. They're always going to make you simplify it down. So this is just a binomial times a binomial, or any polynomial times any polynomial. It means multiply everything times everything. So using whatever method it is you use, there we go, sorry, 4m and 4m, negative times negative, right? 16m squared, because negative times negative is positive. 4 times 4 is 16, and m times m is m squared. Negative 4m times 3n, just take it in pieces. The negative 4 times the 3 is a negative 12. Then m times n is mn. Now do the underside. This chunk right there gives me a negative 12mn. And then that chunk, 3 times 3 is 9, with an n squared because of the n times the n. Don't leave it. Look for your like terms. And notice that my middle 2 are like terms. That typically happens when you're working with binomials, especially if you square them, right? 16m squared, 24mn's, and 9n squared. Remember, those first and last ones are not like terms because one of them's an m, the other's an n. So make sure you don't add those together. And that's it. If you're in accelerated, don't forget, write those questions in the summary. If you're in regular, remember that we will write the questions and summary in class together. Just make sure you got all this stuff written down. Easy cheesy 100. Hope you're having a great day, and I'll talk to you guys in class.